Okay, good day guys. Today we are going to be talking about scalars and vector quantities. But quickly I'm going to do a short introduction about scalar and vector. What is scalar? Scalar is any quantity that are described by their magnitude alone. They don't have direction. We have temperature, we have energy, stuff like that. They are scalar quantities. They don't have direction. Direction is not used to describe them. Okay, and calculation on other scalars are just the normal ways. The normal way you do calculation, addition and subtractions. You have 2 meter plus 3 meter. Sorry, 2 kg plus 3 kg. It gives you 5 kg. Straight away. This is an example of scalar quantity. When we talk about vector quantity is a kind of quantity that is described by their magnitude and their direction. So, and there are 2 different methods that I'll be using to solve this vector quantity for you today because of the direction. Now let's take the example. If you have a force in this direction, you have 100 Newton, you have 80 Newton, and you have another force in this direction. We have, let's say we have 800 Newton here, okay, and we have 80 Newton here. Now for this one, you are asked to calculate the resultant force, and this one also to calculate the resultant force. Now what is the meaning of resultant force? Resultant force is the total force that is gotten using the 2 component forces that we have. Or the resultant force can also be said that is the total force that is resolved after considering other forces applied on a particular body. So we have 2 forces here applied on this body. There's an object, let's call this object O. 2 forces applied on this body. The first one is 100 Newton, the other one is 80 Newton. Now if you are told to calculate the total force that this guy is experiencing, this body is experiencing, because they are both on the same direction, we are going to have it as total force resultant is going to be 100 plus 80. So you have your resultant force here to be 180 Newton. It means that this particular body is going to be experiencing 180 Newton force applied on it. Normally, practically, if you tie a rope to this body now, the rope, let's say a particular part of that rope is the force of 100 Newton is applied, dragging this body, another 80 Newton is dragging it. They are both dragging this guy on the same direction. So the guy is going to move under the force of 180 Newton. Because this body is going to be experiencing 2 different forces, 100, the other 80. Both of the forces are being applied on the same direction. So this guy is going to move towards this direction with 180 Newton. Now let's look at this other one. This particular body is experiencing 100 Newton on this side, another 180 Newton on this side. So this body is just at the center. There is a force applied to it on this side, dragging it towards the left hand side, 100 Newton. Another force dragging it towards the right hand side, 80 Newton. Now these 2 forces now, to get the resultant, if you are going to resolve this force, because 100 is greater than this 80 Newton, this body is going to move towards this left hand side at the end. But it's going to be experiencing what? 100 minus 80. That is 20 Newton is going to move this body to this side. Now 80 is going to be subtracted from 100. This one is a force on its own, but because there's an opposing force towards this force, now you have to subtract. They are going to be on different directions, so you have to subtract. This one is trying to pull this one back, but this one has more energy than this guy. So what this guy is going to be experiencing as a force that will pull it is 20 Newton. So the force that is going to pull this object, like I said, is going to be 20 Newton. So what is the difference between what I've explained now? When you have it on the same direction, you add. When you have it on different direction, you subtract. That is the basic knowledge for vector. but then we can still have more explanation to it when it comes with dealing with directions under a particular degree, that is angle and whatever. So we have two different methods that we can use to solve vector, to resolve vector. Now the first one is going to be triangle method, and the second one is going to be parallelogram method. I'm going to explain these two methods. Okay. So quickly, what we have here now is when you are going to use triangle method, majorly when you have your angle at 90 degree, when you have your angle at 90 degree, say that you have a force Fy and you have another force Fx moving in this direction. Now if you look at this, you can't just say that, let us say Fy minus Fx should be your resultant. You can't just say that you don't get the answer because of the presence of this angle that is in between them. So before you can solve this guy, you are going to use what we call Pythagoras theorem. Now at this point you have 90 degree. Okay, the resultant force that will be experienced will come from the center in between two of them. Alright, and it's going to be a diagonal force. Now this guy now should be our resultant R. So you are going to be having a resultant coming from the middle, the center of Fy and Fx. Okay, if you look at this particular shape I have on the board now, you see that this Fy, this side and this side should be equal. If this side is Fy, this one too should be Fy. If this side is Fx, this side should be Fx. So whatever value you have here is the same value you will have here. Whatever value you have here is the same value you have here. So you can see that I formed a particular triangle now. I formed a particular triangle. And looking at this, you have something like this. Fy and Fx. Now at this point you have your 90 degree here, and this is your resultant force R. So your R basically is going to be, from your Pythagoras, you have it as hypotenuse square is equals to opposite square over plus adjacent square. So you have it as R is going to be square root of Fy square plus Fx square. That is what you are going to have. That is for the triangle method. So but for the parallelogram method, when you have an angle below 90 degree, that is an acute angle, that is when you'll be talking about the parallelogram method. It's going to lead you to parallelogram method. So quickly, I'm not going to explain these methods before we launch into calculations, so that it will be easy for me when I'm explaining. So let's say we have an acute angle like this. A particular force Fy is making an angle with another force Fx. Alright? So and we are told to calculate the resultant force R. How do we do that? The resultant force is still going to come out from the center of Fx and Fy. So you are going to have something like this. Alright? We're going to be having stuff like this because it's going to come out from the center. Now do not forget that this angle that we have here, the angle that Fy is making with Fx is less than 90 degree. So it's an acute angle. So let's take this one as our theta. Alright, this angle, let's just take this whole angle as our theta. Alright, so okay, transferring this particular force to this side, since this side is Fy, I can make this side look like Fy too. Whatever we have there, we have it here, and whatever we have down there, we have it here too. So obviously this looks like a parallelogram. You have Fx. Alright, so at this point, remember from your deductive proof, alright, you have whatever angle that you have here is the angle that you have here. So if this side is theta, this side too must be what? Theta. Alright, I'm transferring the angle now. And at this point, remember that angle on a straight line is equal to 180. So if you have angle of it on the straight line to be 180, what you have here is 180 minus theta. Alright? So, and at this point, another thing that you need to watch out for is that we already have a parallelogram style or shape of the board. If I'm going to bring out this that I have, this particular angle from this side to this side is the theta. But now if you look at this side, from this point to this point cannot be theta again. So let me call this side my alpha. From this point, let me say that again, from this point to, from the beginning to the end is the theta. But from this point to this point cannot be the old theta, because it's going to be taken out of that theta. Like the value that we'll be having here is not going to be up to the theta, but it's going to be less than the old theta. So this side, let me just call this side alpha, and this side now is going to give me to determine my direction for my resultant. I'm going to be using this theta to determine my direction, because you can have a question that can say that calculate the direction of the resultant. So at this point now, let me bring out my triangle. You are going to ask something like this. This is what we'll be having. We're having stuff like this, and at this angle we have it as alpha. Then let's call this one our resultant. This is our fy, and this one is our fx. Alright, then this one should be our theta, and this one should be our 180 minus theta. Now how do I calculate? If I want to get my r, there's a general formula that you just need to know. Continuously now, consistently after this explanation, I'm not going to be talking about this, how to get this formula again. I'll just be launching to the formula straight. Now to get your resultant r, you are going to use cosine rule. I'm going to use cosine rule. If you look at cosine rule, normally cosine rule says that you have your a squared is equals to b squared plus c squared minus 2bc, alright, cos a. That is your cosine rule. But at this point now, we have our r here, we have our fy here, we have our fx here. So if I say r squared, alright, is going to be equal to fx squared plus fy squared, right, minus 2fx fy cos 180 minus theta. Okay, now you know that the opposite angle to r is 180 minus theta, alright, and fy and fx, they are the components out there that we can use to fill in for the resultants that we have there. So at the end, we have our r to be equal to square root of fx squared plus fy squared minus 2fx fy cos 180 minus theta. So with the help of this, we'll be able to get our resultant. So I've given us two different formulas now. This is for the parallelogram, and for the triangle method, we just have it to be fx squared plus fy squared. There is no any angle that we are going to consider for that calculation. So now we are going to go into calculations.